Hey everybody, this is Larry. This is day 27 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, drop me in Discord. Let me know what you think about this one. Apparently they've been doing recent contest code or something. So yeah, so I guess my code's already been thing. And this Halloween Thanksgiving thing. Yeah, I hope everyone's enjoying this short week or whatever. If you're in a country that celebrates Thanksgiving. Otherwise, also just hope everyone's just having a good rest of the week. Let's take a look at today's problem. Today we have 3243, shortest distance after road addition queries 1. I think there's a harder version of this probably. But because I don't remember this one, but I remember the graph kind of looked similar, but I don't know. Anyway, you're given queries, the end cities. Okay, and there's a road from I to I plus 1. You have queries that represent new direction. Oh, I think this is the Q4 in which I did not get, maybe. And it just turns out to be, I think that particular problem turns out to be case analysis. The medium problem is probably way more reasonable. So we'll take a look. So I do kind of remember this one, a little bit cheating. But I remember just like something, if I had to guess, without finished reading, is just like the shortest path, given that they're next to each other, but you can also, they're like these jump stations or whatever. But all right, let's take a look. Query survive represents the addition of new road. After each query, you need to find the length of the shortest path. Oh yeah, so it's live and all these things. Okay, so okay. So this is the medium version. I think the hard one I just didn't get during the contest. I guess that one was memorable. Even though I forget why though. Maybe I'm thinking of a different problem. I don't know anymore. Every problem kind of feels the same at some point. Okay. So okay. So what are the constraints? The first thing I want to check are the constraints, because the difficulty of this problem depends on the constraints. And given that n is equal to 500, actually is not that bad. Why? Because for each query, we have 500 queries as well. So you have n and q as two variables. N is the number of nodes, q is the number of things. And for every q, you can just manually do a O of n search, and that'll be fast enough. And of course, it should be O of n because, so if you do n times q, it's going to be way fast. You can even optimize, you can even not optimize, but even if you have a slightly slower solution, it's probably fine to like an n log n type thing, for n is equal to 500 and q is equal to 500. So we definitely can consider that. Yeah, I think that's enough for me to kind of get started, just because this is going to end up relatively brute forcey, but yeah. Length of the shortest path from 0 to n minus 1. So this is actually, I forgot, this is the shortest from this thing, right? Yeah, okay. So then that means that in the beginning there are there are no things, right? So here you can maybe think about it as, okay, so maybe you could just first write out the distance, right? So let's just say we have none times n, and then for well, the 0 no is going to be 0 for obvious reasons, and then now we go from n to n, something like this, right? I mean, obviously you can write this another way, but the reason why I write this way is that it is close to what the problem is saying, right? You know, I mean, and of course you can collapse this to realize that it's just I or something, but like I said, this is more, you know, for me, it just means that it represents what the problem is asking, right? And it also makes it easier that if you have to change certain things because you misread it, then you're like, okay, well, you know, we didn't pre-calculate it, but yeah. Anyway, all right, and then now we have a query. So now for SE and queries, right? So then we want to say, yeah, actually, maybe wait, did I go too fast? And Am I being silly? Huh. But yeah, do, do, do. I think I'm just trying to think about which way I want to do it. For some reason, I thought it would be a little bit more simple, but maybe I'm wrong. Maybe this is not as easy as I thought it would be, which happens from time to time, or maybe more often. But yeah, because I'm trying to think about. Um, I think I missed a part about this problem. Or maybe not, I don't know. Maybe I'm thinking of another one, really. Give me a second. I feel like something's weird. Am I thinking of a different problem? Maybe I am. So this is at least one, left, right, but... I'm thinking of a problem where, yeah, maybe I'm thinking of the wrong one, actually. I don't know. Everything feels similar, like I was saying. Sorry, friends. Sometimes that's the live portion of it, right? If I just knew the answer for every problem, then or solution for every problem, then this wouldn't be live. It's just me kind of schmucking around. But no, because there's none of them are in examples, but I feel like maybe like there's a version of this problem or similar to this problem where the two the roads don't cross, if you will, and that's a different problem because from that there are like different assumptions that you can make, which I'm trying to which for some reason I guess maybe I just kind of remembered it enough that I was leaning toward, but now I'm like, the problem, it doesn't actually say that, right? And what I mean by that is that like if you look at a 3-node problem, you cannot have a query that goes from 0 to 2 and then 1 to 3 because it crosses over, right? I think that maybe that's a different problem. I'm trying to find, maybe I'm just getting confused, but yeah, maybe I am just getting confused. The reason why I'm hesitating is because I was going to do a naive like dynamic programming thing, but the thing is that if you're not careful about previous edges, you can very easily run into n times q times q, which is like, well, not so fast, right? That's why I'm like kind of hesitating, and maybe I rushed this one a little bit in the thinking process. Let's see, right? Yeah, maybe I am thinking of the wrong problem. I'm so confused today, but okay. But okay. So I think the first thing to notice, then let me refresh myself. We kind of like rejoin the problem and refresh. Sometimes I would say just in general, the hardest part sometimes is when you're stuck on an idea and you can let go, and I mean, which is fine, like, you can explore during training and everything, right? But during a contest or something like this, you have to be realized to like, and that's what happened to me, like, was it this week? I think it was this past week on a bi-weekly where I just got stuck and I just couldn't let go to go Q4 even, right? Which I could have finished. So it happens from time to time. And sometimes in the past, I am a little bit better. Sometimes I'm not. So I don't know. But you have to be able to think about restarting, right? Everything you've done is sunk cost. if you start afresh and there's another way, then you know it's a little bit better. Okay, so let's start over a little bit in my heads anyway. What is the answer, right? Well, what are the observations, right? The first, well, I mean not the first anymore, but the first new observation is that, well, the answer will only get smaller, right? Because, yeah. The answer will only get smaller. I'm still thinking about the one where it can cross, which is the confusing thing, because the second idea that I had was like using a linked list and then removing nodes on the linked list or something like this. But yeah. So the answer cannot get bigger because adding a query will always, you know, be better. But does that do anything for me? Because yeah, initially I was just gonna run like for each query, and then after you add this, then you do a dynamic programming, which actually should be pretty okay. But because then, okay, let's see, right? So then now, after you add an edge, no, I'm just dumb. Okay, I see. I analyzed it wrong. Okay, no, okay. Yeah. So the reason why I analyzed it wrong, well, it's not the reason, but one thing I analyzed, yeah, I just analyzed incorrect. Sorry, friend. No, my initial idea is right. So some days it's just, I don't know, like, even when you're right, you're wrong. But what I wanted to say was that, okay, yeah, I mean, at least I was articulate about what I was analyzing wrong, because I thought that for some reason I wrote, because as I was saying, and these things sometimes you have to draw it out in things to make it easier to analyze. So I was saying that you know, you do something like this, it'll be too slow. And the reason why I thought it would be n times q is because for each node you can get. I thought that you may be able to hit. Yeah, I don't know why that made sense to me, honestly, now that I see it. But the actual answer is that, okay, so the first iteration of this, right, you're going to have n edges, right? Even if you kind of implicitly, but also even if you just create them explicitly, being like 0 is connected to 1, 1 is connected to 2, and so forth, right? And in the second one, what is going to happen? Well, n plus 1 edges, right? Because then now you add one previous edge, and n plus 2 edges, and so forth, right? So then, okay. So what does this add up to? Well, if you take out, because there are q queries, so that's the last number. If you take out the n, then it's just going to be O of n times q, right? Because there are q of these, and the n plus 1 plus 2, plus 1 plus 2 plus 3 plus 4 plus ... plus q, and the second part is roughly n squared. I'm too lazy to, you know, do it, but so, and of course this is going to be fast enough, right? Yeah, this should not. Also, this sales thing blinking is very distracting. I don't know if you can see on the Thanksgiving thing, but in any case, yeah. So this is going to be fast enough. That I don't know. I think I got confused because I thought I was thinking about a different problem, but. Yeah, I guess it's just a prize here. Anyway, so this is the reason why I can do it, and this is why I don't know how I got n times q confused. Okay, but yeah, and then now we can just do yeah, we could connect s and e together, and you could write this in either way. Actually, I think you don't even need this anymore, honestly. At least not like that, right? So you can have something like this, right? So then now maybe we have something like edges is equal to yeah, maybe I like it like collections default text of list, and it basically is that yeah, that is equal to s, right? And you could go the other way from left. You could either go from left to right or right to left. For this problem, it's symmetric, so it doesn't really matter as much as long as you understand that, so that if things change in the future, you know that you can't always do it. But yeah, but we're going this way because I want to go from end to the beginning, right? So yeah. Actually, I guess I have code that kind of like this, so I'll just do it this way. But it also kind of talks to what I was saying earlier, right? With respect to having the function like this, then now we can also, you know, just kind of add a thing, which is that if or for I don't know, for previous in edges of I, right? Dist of I is equal to distance of p plus 1 as a candidate, so we want the min of this, right? So something like this, right? Yeah, and at the end, not return, but we just append distance of the last node, and we should be good. So pretty okay. I think I just kind of confused myself a couple of areas, and apparently missing some stuff. Oh. Oh no! Now we went back forward. Okay, fine. Because we're looking at the previous thing that's connected to it. Okay, I did confuse myself. Oh, what am I doing? This isn't even. As you can see, some days are just a little bit weird. I hope I don't get a wrong answer this time. What did I get a wrong answer on last time? Doing the contest too, probably. I did it very quickly. Did I just start off by 1? What is the... how did I fix this? I'm just curious from past there. Sorry, a little bit distracted. Man, I end up... The BFS is right. And this time I did the DP as well. Apparently only 3 months ago. Why are they giving a daily problem 3 months ago? But in any case... I guess 1335. Why do I get 4? Huh. I mean, I guess I have to watch my old video to see what I did. I actually don't know why this is wrong, because it feels very similar to what I'm doing today. The way more code, but. Oh, I see. I'm just updating it from there, but it can affect the future. I don't know why I thought that. Okay, I see. And then today I just basically did what I did today, except for I did it with a breadth first search that time. Yeah. I mean, same idea, right? I mean, I did DP. I actually also thought about using top-down memorization, but yeah. But the complexity is going to be n times q, as we said, because the hard part, which I got confused about, which you saw, is that edges will only have, we did the math, right? We'll have n plus q as the maximum of edges. So this is pretty straightforward. And this loop is just q. So then you have like a verse. I wrote this a little bit differently because you can also, what I was going to say, which is q times n plus q, which is actually maybe more straightforward in terms of like analyzing it this way. But yeah, it's going to be just like 500 times 1,000, which is going to be, pretty Gucci. Anyway, that's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.